Control structures, looping. Objectives. In this lecture, you will learn about repetition, looping, control structures, learn how to use a while loop in a program, learn how to use a for loop in a program, learn how to use a do-while loop in a program. Why is repetition needed? Repetition allows for efficient use of variables. We can input, add, and average multiple numbers using a limited number of variables. For example, to add 5 numbers, we can declare a variable for each number, input the numbers, and add the variables together. Or we can create a loop that reads a number into a variable, adds it to a variable that contains the sum of the numbers. While looping. The syntax of a while loop is while, then the expression statement, where the expression statement serves as a decision maker and is usually a logical expression. It is important to remember the parentheses are part of the syntax. A while loop statement can be simple or compound. The following figure demonstrates a simple while loop. An expression is evaluated, and as long as it is true, the statement will get executed. Once the expression becomes false, the loop will end. Let's look at an example. Consider the following code in example 5-1. The variable I in example 5-1 is called the loop control variable. We can see in line 2 that the loop will run as long as the loop control variable is less than or equal to 20. Once I exceeds 20, the loop will end. The sample run produces 0 on the first pass, 5 on the second pass, 10 on the third pass, 15 on the fourth pass, and finally 20, which ends the loop. For looping. A for loop is generally used to repeat a single statement until a condition is met. The syntax of a for statement is for, the initial statement, then the loop condition, then the update statement, and then a statement. The initial statement, loop condition, and update statement are called for loop control statements. The following figure illustrates a for loop. We are given an initial statement which evaluates to true. Then we start our loop condition followed by our statements. Then our update statement. And we repeat our loop until our condition is false. Once the condition is false, our loop terminates. Let's look at an example. The following for loop prints the first 10 non-negative numbers. The initial statement, I equals 0, initializes the integer variable I to 0. Next, the loop condition, I is less than 10, is evaluated. Because I is less than 10 is true, the print statement executes and outputs 0. The update statement, I, then executes, which sets the value of I to 1. Once again, the loop condition is evaluated, which is still true, and so on. When I becomes 10, the loop condition evaluates to false, and the for loop terminates. And the statement following the for loop executes. Do while looping. The syntax of a do while loop is do followed by a statement, then while followed by an expression, then a semicolon. The statement executes first, and then the expression is evaluated. As long as the expression is true, the loop will continue. To avoid an infinite loop, the body must contain a statement that makes the expression false. The syntax can be simple or compound. Loops always iterate at least once. The following figure illustrates a do-while loop. We can see we have an incoming statement which leads to an expression. As long as the expression is true, the statement will continue to execute. Once the statement becomes false, the loop will end. Let's look at an example. The output of this code is 0, 5, 10, 15, then 20. After 20 is output, this statement, I equals I plus 5, changes the value of I to 25, and so I is less than or equal to 20 becomes false, which halts the loop. Choosing the right looping structure. All three loops have their place in C++. If you can determine in advance the number of repetitions needed, the for loop is the correct choice. If you do not know and cannot determine in advance the number of repetitions needed, and it could be 0, use a while loop. If you do not know and cannot determine in advance the number of repetitions needed, and it is at least 1, use a do-while loop. Break and continue statements. Break and continue alter the flow of control. A break statement is used for two purposes. One, to exit early from a loop. You can eliminate the use of certain flag variables. Or two, to skip the remainder of a switch statement. After the break executes, the program continues with the first statement after the structure. Continue is used in while, for, and do-while structures. When executed in a loop, it skips remaining statements and proceeds with the next iteration of the loop. Our summary. C++ has three looping structures: while, for, and do-while. While, for, and do are reserved words. While and for loops are called pretest loops. Do-while loop is called a post-test loop. While and for may not execute at all, but do-while always executes at least once. While the expression is the decision maker and statement is the body of the loop. The for loop simplifies the writing of a counter-controlled while loop. Putting a semicolon at the end of the for loop is a semantic error. Executing a break statement in the body of a loop immediately terminates the loop. Executing a continue statement in the body of a loop to skip the next iteration.